In this video, we're going to find the volume of the solid generated by revolving the region bounded by y equal x squared plus 1, which is a parabola with vertex at 0, 1, y equals 0, which is the x-axis, and x equal to 0, which is the line for the y-axis. And then we also have the vertical line x equal to 1. And we're going to revolve this region about the y-axis. So this is what the region looks like, which passes at this point here on the parabola 1, 2. Plug in 1 there, 1 squared is 1, and this we get the 2. So we're looking at this region right here, right in here. So we demonstrated this kind of problem using a disk method, sometimes called the disk washer method, depending on the value of the smaller radius, whether it's equal to 0 or not. So if you're going to use the disk method, the rectangular strip has to be perpendicular to the axis of revolution, which in this case is going to be the y-axis. We have to look at this region here. Now notice though, on the y-axis, the values go from 0 to 1, and then from 1 to 2 to cover the region. So if we're below this line here, we're looking at integration with respect to y, of course, because you have perpendicular rectangle. And the region is on the interval from 0 to 1. So in here, the limits of integration will go 0 to 1. But when you're above this line, say in here, you're going to go from 1 to 2. Not difficult, but just a little bit more work. So we'll set this one up after we do it the method I prefer, and that's with the shell method, where in this case, as we saw on the previous video, the rectangle has to be parallel to the axis of revolution, which is the y-axis. With the disk method, or the disk/washer method, the rectangle has to be perpendicular. So what we need here, we rotate this, like I said, around the y-axis. So in this case, because this is perpendicular, parallel to the y-axis, but perpendicular to the x-axis, the variable of integration is x. So this would be the width here, or thickness of the shell as it rotates, dx. And then h of x will be the length of the rectangle. So we need this distance here from the x-axis here to the end of the rectangle. So length of rectangle is height of the shell. And this distance in this region here is just from the x-axis to the curve, which of course is going to correspond to the value of y, which is x squared plus 1. And then the radius is the distance between the axis of revolution and the center of the rectangle. So here's the axis of revolution, and then from here to here, that's going to be x, that distance right there. So here's the formula. Volume of solid revolution. And again, it's based on the volume of a shell, which is 2 pi, the radius as described here, the height as described here, times the thickness of the shell, or the width of the rectangle, which is dx. So we said the radius is x. From here to here, that's x. And since we're integrating with respect to dx, we don't have to do any conversion. We just put it in there. And then the height, this distance here, from the base here, is just y, or x squared plus 1. And of course the thickness of the shell is dx. So just plug these in. 2 pi, that's a given. That's part of the formula if you use the shell method. And the integration goes along the x-axis. So that was from 0 to 1. And the radius we said was x. And the height was x squared plus 1. The width, of course, is dx. And then we just integrate with respect to x. So we got the 2 pi here, multiply by x, we get x to the third, plus x, dx. Then we just integrate here with respect to x. Integrate here, x to the third, respect to x, add 1 to that, gets x to the fourth, divide by the 4, and the x, same thing, integration with respect to x, add 1 to the 1, we get x squared, divide by 2, that's the exponent. Then we're integrating here, limits of integration go from 0 to 1. Now we just plug in there. So we get the 2 pi, and we evaluate this thing at 1. So it'll give me 1/4 here. Place the x by 1. 1 to the 4th is 1, of course. Gives me the 1/4. 1 squared is 1. And then it's minus the lower limit, 0, 0. So 0 to the 4th is 0 over 4 is still 0. 0 squared is 0 over 2 is still 0. So this just gives me 0. So this will give us 2 pi. Combine this, 1/2, or 1/4 and 1/2. Gives me 3 over 4. And reduce this here. 2 into 4 gives me 2 here. So this will give us 3 pi over 2. And remember, we're calculating volume, so the units here are not given, but this would be cubic units. So the volume for this region that's generated here is 2 pi over 2 cubic units. And that's your answer for this one. And notice, we didn't have too many steps there using the shell method. If you want to use the disk method, like I mentioned, you'd have to go this way. For the disk method, the rectangle has to be perpendicular to the axis of revolution, which is the y-axis here. So you'd have to do this. So the rectangle would have to go like this on the region from 0 to 1 here. And from 1 to 2, it would have to go like this. So there, remember, you have to find the radius, the outer radius, and then the inner one. Now the first region here, from 0 to 1, only has r. From here to here, that's 1. So r is going to be 1. Since the region coincides, the edge coincides right there with the x-axis, y-axis, little r is 0. So we're going to have 2 integrals. One from 0 to 1, one from 0 to 2, and the first one's going to have the outer radius equal to 1, and for the second region, r again will be 1, but this time little r would be this distance, which will be 1 minus this distance, so it'd be 1 minus x. So the outer radius would still be 1, but now the smaller radius would be 1 minus x. But in this case, see, the rectangle has width equal to dy because it's perpendicular. It's perpendicular to the y-axis. So when you set this one up, the formula you're using is this one right here, because we're integrating with respect to y. So in the region from 0 to 1, this r here is 0, and the outer radius is 1. So this is going to be 1 squared. This is just going to be 1 squared here. Now when you get to the region on top of that, then you go from 1 to 2. R is still 1, but the inner radius now is 1 minus x. But in this case, you got to solve this. You got to solve for x squared, or x in terms of y. So take that over to the other side. We get x squared is equal to y minus 1. Take plus or minus the square root, plus or minus. But since we're in the right side of the y-axis, or on the positive side, we use a positive, the square root of y minus 1. So when you put all that together, this is what we get. Same problem here, same answer, different method. So right here, in the first interval, first region separates a region into two regions. So from 0 to 1, the outer radius is 1, so it's 1 squared dy from 0 to 1, and then again Here the formula, of course, is pi r squared, because we're looking at a disk, volume of a disk. And over here in this one, same formula, except we have the two radii. Capital R is still 1. We have 1 squared pi r squared minus, and this again, this x, but and this is with respect to y here. Integration is with respect to y, so this should be a y here, dy. Then you just square this out, square this, you get 1 minus y. So this comes out to 1 here. You square this, and then you minus, so it's going to be a minus y, then minus minus will give us a plus 1. So it comes out to minus 1 plus 2. And then the integration is with respect to y, evaluated 1 and 2. This one, of course, is just going to be y, evaluated at 1 and 0. It's just going to give you a pi y there. And then you can do it with this one also, evaluate it. And you should get the same answer that I got using the shell method. But there's your setup here, with again this being with respect to y. Thanks for watching. We'll see you next time.